All right, let's do the BAP review. Start with question number 1. Under which of the following circumstances should the analyst recommend the removal of the listed unvented heater according to ANSI BPI 1200? So, the clue is to, if you're going to use your resources, you can search it, but you have to do hotkey searches. So, you would look up the BPI 1200, and it has it in the resources. I'm going to look it on Google right there. But this is how you should study for your exam. Use Google. All right. So Control F is how you do your search. Now, since it's asking about unvented heaters, so just go unvented. There you go. Unvented heaters. So let's read it real quick. It says maximum, the heater input is maximum of 40,000 BTUs, but not more than 10,000 installed in a bedroom, 6,000 installed in a bathroom. So let's look at our answers. Well, they have 40,000 in the living room, that's fine. 6,000 in the bathroom, 15,000 in the bedroom, so that's 5,000 too much. So that's going to be our answer. And then it has our 22,000 in a garage, but we don't care about the garage, that's not living space. So our answer will be 15,000 BTU. Okay? Next one, number 2. If a natural draft furnace fails the spillage under the greatest combustion appliance zone depressurization, regardless of the Cazador position and air handler operation, what should the appropriate response be according to the BPI 1200? Well, when we're doing depressurization, we only test it for 3 things, right? We test it for the air handler, door position, and exhaust fans, right? So before even looking at the possible answers, I'm going to try to answer the question. The thing is going to be something with the exhaust fans. Now let's see if that's our answer. Recommend further evaluation by a qualified professional? Well, yeah. No matter what the problem is, that's true. Conduct further testing to determine if leaky ducts are the spillage? No. Leaky ducts, air handler has nothing to do with it. Recommend measures to improve air transfer between the CAS and main body of the house? Well, it says the CAS door position doesn't matter, so it can't be that one. Disconnect mechanical ventilation systems until further tests have been conducted? Well, that doesn't make any sense. Okay? We're not going to, no recommendation says disconnect it. So recommend further evaluation by a professional. Of those answers, that's the one. Because the cause of the spillage has been determined to be, have to do with the exhaust. All right, 3. What's the primary purpose of mechanical ventilation per the BPI 1200 standards? But what's the point of ventilation? Is it to regulate indoor relative humidity? No. Is it to dilute indoor air pollutants?
Yes.
Yeah, that's a pretty good answer. We'll put a pin in that one. Remove offensive odors? Primary purpose? No. It can do that as well, but it's not the primary purpose. Ensure adequate combustion air? No, that's not mechanical ventilation's job. Okay? So of those, instead of jumping into the standards, I could sit in here and search and search and search. Or I could just know the answer. I know why we do ventilation. Why do we add mechanical ventilation? Lots of reasons.
Can you go back just to standard?
Does that sound sure? Recommend the removal of indoor air pollutants. Let's see. The project documentation shall specify improvements as required to reduce pollution sources and to provide adequate ventilation consistent with the design strategies. And then all these other things. So you can spend 10 minutes reading all that, but what's the point? Well, we're trying to dilute contaminants, air quality, bring in fresh air. According to ANSI 1200, let's jump into the standards again. Well, let's pause. Let's see if we can answer the question. before jumping into the standards. According to the standards, what's the correct response when a furnace fails a spillage test, regardless of the CAS door position and air handler operation? Well, what does that tell us about the furnace? If it's failing spillage, what kind of a furnace is it? Natural draft, induced draft, or sealed combustion? Natural draft is the only one that can spill. Okay, so and the air handler operation and the door position don't matter. So do we disconnect the mechanical systems until further tests? No. Recommend measures to improve air transfer between the CAS and main body? No. That just recommend further evaluation? Oh, yeah, sure. Yeah. All right. Are we going to get more specific than that? I don't know. Maybe. Conduct further testing to determine if leaky ducts are the spillage. Well, we know the air handler doesn't have anything to do with it. Okay.
It's really hard to like pay attention to the words and the terminology.
Yeah.
Each answer, yeah.
Know what the question is asking you, so that you can eliminate the ones. Well, yeah, you test the ducts. Well, you sure test the ducts, but that's not going to solve this problem.
I still don't totally understand what the air handler actually is.
It's the thing that blows the air through the house.
It's the thing with the fan in it, right?
It's the fan that blows,
Blower.
sucks air from the house.
The furnace is the blower right there. on
The
bottom.
furnace is what heats. The air handler is what moves air. Most furnaces have an air handler. If it moves air through the house, everything has an air handler, but it doesn't necessarily have a furnace. It could be have an electric heat pump. You could have hydronic system through it. The air handler is what handles the air. It pulls air and then distributes it through the ducts.
Keywords.
Yeah.
Yeah. Like plenum
No, the plenum is just what holds the air.
holds the air.
The thing that's moving the air, that handles the air, is the squirrel cage. It's the fan. It's literally the fan.
But there's a fan in there.
Yes, that's the air handler.
So that's the air handler?
Yes.
Yeah, sometimes it'll be in the attic, sometimes it'll be in the
Yeah.
vertical unit, the
That
closet.
bottom section,
Yeah.
there's the air handler, there's the furnace section where all the burners and everything, the heat exchanger, and then on top of that is the air conditioner. Though the heater and the air conditioner are what condition the air. The ducts, including the plenums and the returns,
Just distribute.
will direct the air and collect the air, and the air handler, the fan, is actually what's moving the air.
Okay.
So the air handler, some people say air handler fan, and we can turn the fan on or off. The air, if we want to turn the air handler fan on, we turn the fan on. Okay.
So let me look at the question and know that I know what it's talking
Okay. So with the ducts charged, pressurized, it doesn't make any difference. It's spilling regardless of the fan on or off. So it's got to be something else.
In which case, you recommend further evaluation.
Yeah.
So disconnecting the mechanical ventilation system until further tests have been conducted would not be correct.
No.
Because-
Well,
Well, I guess,
because then you wouldn't have any, like bathroom fan. We're going to disconnect our bathroom fan and our kitchen fan until we can figure out what's going on with the furnace.
oh, like, it's that.
It's that simple.
Yeah. It says systems.
Let it be easy. These are not
Yeah,
complicated.
it gets kind of
systems.
convoluted with
Yeah.
all the letters and numbers and the terms and all
Yep.
that type of stuff, yeah.
Oh, if it said disconnect mechanical ventilation, ventilation system, no. I thought that question, or that answer was referring just to just the air. I thought it was like turn it off until we look at it further. Like basically the right answer, but turn it off. Whatever.
I mean, well, still that's not the answer.
Yeah.
Because that's what's causing the problem. So if you turn them off, you can't. If you're testing without causing the problem, there's no problem.
Right.
So disconnecting them would take away the problem without fixing the problem.
Right.
You know what I mean?
Yeah.
Okay. So that's not recommended. Just identifying the problem, so that we've identified the problem as a problem with a lot of exhaust, So now what the solution is not to remove the exhaust, it's to isolate and ventilate to the outside so that we can get that air movement. Is that clear?
Yeah.
Okay. So we're on 5. This is a combustion air calculation worksheet, which is used to determine if additional air is required in the combustion appliance zone. Based on the data provided, is additional air needed? Look at that scary, complicated form. All that information. What is it asking us for? Is additional air required?
Yes.
Additional air needed? Yes. Okay.
I'll be honest with you, I completely missed that when I was reading this form. I was like looking at the numbers and trying to compare.
Doing this? Yeah.
That's crazy.
Required volume? Required volume? It's not 0. Okay.
Literally, is additional air needed? Yes.
I got right.
But even if you look at step 3, it tells you if the numbers are
Yeah, if you do the calculation,
if it's
you're under
sufficient.
50.
Oh yeah, by the way, this is that
Yeah.
50 per thousand.
I did the calculation. I've never looked at the check mark on
Yes.
Read the form. Got it.
I missed the check mark.
Well, read the relevant thing. So it says step 3 is that's our results. It has our inputs and all that stuff. There's going to be lots of information, but it's about taking the form and getting the information that you need. And reading the entire form and every letter on it is not necessary. You just need to go to the section that is relevant. Like if you come into the house with our CO reading in the house and it's 5, we don't care what it is over 70. We need to know what it is at 5. Proceed with work. Understand? Same thing. There's a lot of information. Grab the information that's actually pertinent. So on this one, yes, additional air is needed. These types of appliances do not need additional combustion air. Why the form then? Why would you do a form if you never need them? Okay, that's silly. Cannot be determined because the report is incomplete. It's pretty complete. It looks all filled out. No additional air is not needed. Well, this says yes. Okay, pretty clear. 6. Which measure is best for reducing elevated indoor moisture levels in a home located in a heating-dominated climate? If it's a heating-dominated climate, what's it like outside?
Oh, hot.
Oh.
Heating-dominated?
Oh, hot, yeah.
Arizona, we crank that furnace.
Heating.
If it's a heating-dominated, so we're going to be adding heating, that means it's cold outside. So if it's cold outside, we're in a home, it's cold outside. That's what we know. So insulating the attic with craft-faced bats. Is that going to reduce our moisture? If it's cold, because the attic should be cold, right? So cold air doesn't hold a whole lot of moisture. Let's see. Air sealing penetrations between an attached garage and the living space. The garage should be cold too. And what's producing moisture in there to be coming into the house? You should have 0 communication with the garage anyway, let alone moisture. Air sealing penetrations between below grade spaces and living spaces. So that assumes that there's a crawl space. We're on a slab here, but if we're on a crawl space, what do we have down there? Bare dirt. And bare dirt releases moisture. And that bare dirt under the house is not as cold as outside. It's warmer because of the house. Okay, it's an enclosed crawl space. Even a vented crawl space is going to be warmer than outside because the heat radiating down from the house. So that sounds pretty good. If we can air seal the penetrations, air movement, that moves the most moisture in and out and around homes. So let's see, that sounds like the best answer so far. Replacing natural gas combustion appliances. If they're spilling so hard that they are putting moisture into the house, they're also putting massive amounts of CO in the house, and moisture is not the problem. So there's bigger problems with that. So going to be C. Seal that penetrations. That one repeats later too. Okay, 7. What's needed to determine the required whole building ventilation rate? Well, you need to know the area, the volume, right? Let's see. So conditioned floor square footage? Yes. Okay, that's part of that. What's one of those things I just said? That's part of the equation. See if there's a better answer. Total surface area of uninsulated walls. That's irrelevant. Total square footage of passive attic ventilation. Well, that has nothing to do with the envelope at all. Total area of operable windows and doors. Who cares? Okay, no. So on this one, the best answer is your conditioned floor square footage. What action is required if active knob and tube wiring is identified during a visual inspection of the attic based on the standards? Do we replacement by the insulation installer? Well, I was an insulation installer, and when I saw a knob and tube, I had to stop my work. I'm not an electrician. Notation of its presence as a potential hazard. Well, when we were doing our field exam, we specifically said we should note it. That's a problem that could stop work or impair work potentially. So it would need to be noted for sure. Repair by the analyst? No. Removed by the homeowner? No, not necessarily. Their cousin David come over. Now my cousin David's gonna come home and fix that up for me just now. He used to be an electrician. Well, he helped one time. Okay, so no. The best answer is note its presence as a potential hazard. Let's see. We're at 9. Which diagnostic test should an analyst postpone if friable asbestos-like material, we're not qualified to name it asbestos, is discovered during the initial walkthrough? Well, asbestos becomes dangerous when it's deteriorated or becomes airborne or friable. That means able to float in the air. So, which one of these would we not do? Combustion safety test? We can do that. We can do combustion safety. Ambient CO? Yeah, we can do that. Blower door test? No. Ventilation fan flow test? We can do that. Yeah, we can test the fan. No blower door test though. 10. Which insulation material may need an ignition or thermal barrier when insulating attics? So, ignition means fire, right? Heat and fire. Ignition, thermal. So which one should we protect from fire? Spray polyurethane foam? Yes. High density cellulose? That'll actually slow flame spread. Rigid mineral wool bats? That's often used as a fire retardant. Commercially, mostly nowadays. Fiberglass bats generally don't burn. So, an ignition and thermal barrier, generally a 3/8 equivalent to 3/8 drywall, needs to be over it if it's in an unconditioned space like that. If it's in a conditioned space, it needs to be like 1/2-inch drywall.
So, you said drywall then? Is that what you said?
Equivalent to. It can be literally drywall or something that's equivalent to that.
Like some ignition barrier?
Yeah. And thermal and ignition. Thermal in the house, ignition barrier in the attic.
Well, I mean, spray foam is a thermal barrier.
Well, they mean a different thermal barrier.
Insulation. So that question, the thermal barrier is referring to a different word. It's not referring to a normal thermal barrier.
Yeah, it's a little confusing because when we're talking about fire, there's a thermal barrier when talking about fire and foam. But when we're talking about the thermal boundary, that's thermal barrier, thermal boundary. So it's a little bit of splitting hairs, but the thermal boundary of the house is the insulation. The thermal barrier is something that's a barrier, a block between the heat and this thing. You know what I mean?
So that's a different thing.
Yeah, it's a different thing. So when they're talking about, that's why they always have it with ignition. Ignition or thermal barrier.
Okay.
11. Which surface containing lead-based paint has the highest potential for generating lead dust? Well, it goes like this. Friction first. Impact second. Everything else third. Okay? So which one of these is a friction surface? Or is there a friction surface? Windows? There you go. There it is. Wood windows, varnished, yeah, absolutely. Or painted, whatever. So that's going to be your answer. If windows weren't there, the next best one, well, it doesn't have a next best one, but the next best one would be like a door. That's because that's an impact surface. But that friction surface can create that dust, and it's super dangerous. The only thing that's more dangerous than lead dust is vaporized lead. Something that if it heats up and you get the whiffs of it, because you will breathe that in. So if somebody's, like my dad, when I was a kid, he would do reloading, and he had the little Bunsen burner thing melting lead, and you'd see the little wisps of smoke off of it, and that's
Not good.
vaporized lead. If you breathe that in, it's very, very bad for you. Yes. But I'm fine. 12. How many attic vents would need to be installed if the work scope calls for 9 square feet of net-free attic ventilation, and each vent has 144 square inches of net-free area?
9.
What does net-free mean? The size, the opening, minus the screen. Okay? The opening minus the screen. So if you have a 12 by 12 vent, is that 144 inches of net free? Not necessarily. It's 24 by 24 vent, but it could have a net free of 62, which is actually a pretty common number. I install those all the time. So if it has net free 144 square inches, what's the math on that?
1 square foot.
Right, that's 1 square foot. I've seen people do all kinds of crazy math with that. Yeah, but 12 times 12 is a square foot. 12 by 12 is a 144. So 144 square inches is 1 square foot. So if you need 9 square foot, you need 9 vents. Let it be.
I was overcomplicating the shit out of that.
Right. You'd be surprised at how many people just math. 144 divided by 13? Oh, dude. Divided by 11? There's no 12 here, by the way. So, it's crazy. So yeah, 144 square inches is a foot. What is the correct procedure if an area of uninsulated wall missing its exterior cladding is observed during the exterior inspection of a building? So you see it, you're inspecting the house, a chunk of the siding is busted off. Okay? Would you include a temporary patch to staple up some Tyvek so that you can insulate it? No.
No.
Identify any necessary repairs required before you insulate that area? Well, yeah, you're going to need some water stop, you're going to need some siding or whatever it is to repair the damage, yes, before you insulate it. Ask the homeowner, hey, just call a construction company. No. Perform a thermal inspection. Get out your infrared camera to see if you can identify any pathways for moisture infiltration. Yeah, oh yeah, I see it. It's in that big giant hole. Turns out.
Honestly, I was pretty confused by this question. Like, I had to look up what cladding was, and then I was like, okay, it's whatever.
Siding, whatever
It's one of
the
those
house
ones
is made
that's
of.
like one of the more simple ones, but I overthought it too. So
It's easy to overthink.
Identify the repair
Yeah,
before doing any other work.
right, yeah. Like,
But I guess when I
you're not going to insulate a wall with a giant hole in it. You're not going to skip that cavity.
Yeah, we gotta fix that before we insulate this wall.
But like, in that scenario, when you're insulating an exterior wall, you're going to drill a hole in the fucking thing anyways. So that was my.
You're going to drill a hole, not going to
not
rip
like-
a
not have
section
giant
off.
hole.
I was like, why would you fix it all the way if you're just going to put a hole in it anyway? Why don't you just
Right.
insulate it and then?
Well, it depends on how you're insulating it. But yes, you generally do have to get in there.
Stupid answer, which is get your thermal camera out.
Well, sometimes.
hole.
Yeah, at any time, if there's any question and you're looking at the answer and it says Well, sometimes you're wrong. Because it's going to have a yes answer, not a, well, sometimes. It could be argued.
Yeah.
It could be argued, yeah, what do you have to say about that test? It says the test could say you got it wrong.
You ever seen Office Space when the boss are interviewing the guy that's getting fired? And he says he's good with people. He's like, what do you actually do?
So the answer would be, is that right?
Yeah.
So
Yeah, interesting.
on this one, it's going to be identify the necessary repairs before insulating the area. Well, we got that fiberglass up in there, but looks like rain. You better fix that.
Call construction.
Call it construction, but I put some Tyvek on it. Paper towels.
Yeah.
That would just-
Damp newspaper. Cover that right up.
Papier mache.
Yeah.
Okay.
Piñata. Okay, 14. In which condition must an analyst recommend that the homeowner contact a qualified professional for repair before insulation is added in an attic? Air seal, attic pressure boundary. No, I can give the kid next door a tube of caulk and says, go up there wherever a wire comes out, squirt some caulking in there. Okay, not a ton of training required. You don't have to be a super licensed professional to do air sealing. Insulation over non-IC rated light fixtures. Let's get a professional to come in there and do something that's wholly inappropriate. If it's non-IC contact, IC is insulation contact. So you don't insulate over it, professional or not, right? So that's out of the question.
If you call a professional to do that, it's even worse.
Yeah, the professional will come out and like, oh, I'm charging you
Yeah.
for this visit. Closed cavity insulation. Well, it says attic. Attic is not a closed cavity. It's an attic. Closed cavity would be like a wall. Yeah.
Right.
Closed cavity, so you're going to dense pack it or something. Corroded B-vent chimney. Oh, there you go. B-vent, you familiar with B-vent? It's double wall pipe. It's metal double wall pipe. If you see corroded B-vent, there's a problem. Do you need to know what the problem is? No, you just need to identify that there's a problem. Who fixes it? A professional. Because if there's a B-vent problem, a professional needs to fix it.
Oh, it's sharing a vent with another appliance.
No. B-vent just means, it could be a single appliance, but it's just double wall pipe. Like this has B-vent on it. This furnace here. It's double wall pipe. You can look at it later. But if it's corroded, something's going on to corrode it. There's a weird bend somewhere. I mean, how did it corrode? There's a big problem. Somebody needs to check it out and fix it. So we always, so many times, we just hand it off to a qualified professional. Our job as an auditor is to see that there is a problem and make the appropriate
I got
recommendations.
a comment on that. Insulation over you can't insulate over non-IC rated light fixtures.
Right. It's not
So-
rated for insulation content.
Yeah, it's
So you're making a recommendation to a homeowner. You don't have to be qualified. So you want to point that out, that you can't insulate this house because
Until they're retrofitted or
Yeah.
something happens to them. Yeah.
right. It seems like because I got that one wrong. Because I would have, you would have to address that with the homeowner.
But you need to be a qualified
You
professional
need to be qualified professional.
to like take out the halogen light,
Yeah.
put in the little Home Depot adapter, and put in your LED
Or
and
build,
seal it.
or build a box.
Or build a drywall box or something. Yeah. You just need somebody who knows what they're doing, but do you need to be a qualified professional? No.
Yeah.
But just as it stands, it doesn't say retrofit it so that it can be insulated over. It just says insulate over it, which is no, you wouldn't do anyway. So justifying wrong answers is super, super common, by the way. Especially when there's a very obvious right answer. Yeah, but we do that. Well, maybe it's tricking us. 15, a pressure differential measurement of unconditioned space with reference to a conditioned space can be used for which of the following? So we're doing a zone test to a space, a garage, a crawl space, or whatever, an attic. What is it for? To prioritize the locations for air sealing measures? Yeah, that's what all our pressure testing is for, is to prioritize air sealing. Because if I go to an unconditioned space and it says 50, that means there's a perfect seal between, total disconnect between those two places. If it's supposed to be unconditioned and it's 50, it's unconditioned. It's no communication. But if I go into a crawl space and it's supposed to be completely outside and I get a 30, that means I have a 40% connection to the house. And it needs more air sealing to get it to 50. If I'm going to a bedroom, I want a 0. It should be the same as the house. But if I'm to an unconditioned space, I want a complete separation. So determine the effective insulation R value. That has 0 relevance. Measure the CFM of a ducted distribution system. So do duct testing. No, it doesn't tell us anything about our conditioned space, unconditioned space. Diagnose the effectiveness of the vapor retarder. Well, the vapor retarder is not meant to stop air movement, so regardless. You might want to check that later, but that's not relevant to this. Okay. 16. Which diagnostic method can verify if a basement is the major contributor of air leakage in a single-family home with higher than average air infiltration rate? So it's a very leaky house. Recorded during the blower door test. So you're doing blower door test. What can we do to verify that that basement is leaky? Combustion appliance testing. No, that wouldn't tell us anything. Thermal imaging. The basement. No. Zone pressure differential. Oh, there you go. Close the door to the basement. Put it down in there. There you go. Now, oh yeah, the basement's quite leaky. Pressure pan. And then pressure pan the basement.
Yeah. Just
That's
put
a big
the pressure
pan.
pan in the basement and stare at it.
Yep. I made a special one. Oh, I just closed the door and put it under. Okay. Yours is easier. If an attached garage is pressurized with reference to, I noticed a lot of you guys said, with respect to, with regard to. Oh, my good sir. The pressure with regards to you, sir. I always say reference because your manometer says reference. Not respect. With greatest respect, sir. Cracks me up. And this is how you can tell I'm cracked up.
I said yesterday during
On your exam.
I think that's what I would say.
I think all of you said that. Anyway, that's fine. That's why I brought it up. So, if an attached garage is pressurized, okay, pressurized with reference to the conditioned space, the house, what recommendation should be included in the work scope? Well, I would, without looking at my answers, I would try to figure out why is that garage pressurized? That's weird. But the answer is no communication to the house. So let's see if something has that answer. Air seal any surfaces shared between the garage and the conditioned space? Yeah. If it's pressurizing for whatever reason, you want to make sure it doesn't get into the house. Air seal it completely. Install insulation in the walls? Well, it depends on the insulation. If you put fiberglass bats, it's not going to stay air at all. Replace the fire-rated door? Well, that's part of the door, but what about the weather strip? What about the door sweep? But what about all of the leaky stuff?
Yeah.
Install an exhaust fan in the garage, vented to the outside?
So it's just further.
It's like, what's the problem? I don't know.
No, that would actually work.
I mean, it would potentially, if it was sized properly.
What if the house is leaking air into the garage, then the exhaust fan would.
That's okay.
The garage is pressurized.
So that means,
So if you
that means that the garage is more pressurized, it means there's more air.
pushing it into the house. So if you just put more exhaust into the garage, if you were to overcome the pressurization of the garage and made it a negative pressure, now it's pulling air from the house. Either case, you want to separate it from the house.
That's true. It is pushing
Now it's
air.
wasting money.
It's pressurizing the house.
I don't want to think about the second option.
So you're still
Because I'm going to get those in my head right now.
Right. So it's like, yeah, well, that would fix the problem. There's a better answer. There's also source control. Try to figure out why that's doing that. But of those answers, the best one is seal between the house. Okay, in the absence of local codes specifying an R value, what's the minimum insulation rating to be used for insulation of ventilation ducts outside the thermal envelope? It is R8. It is R8. So we have R6 outside the envelope in this place. Inadequate. 19. A blower door test indicates a leakage rate lower than the whole building ventilation requirements. That means it's a leaky house or tight house? Tight house. So it's a tight house. Okay, the house has interior partition walls that are open to the attic. So like where this little knee wall is right here, the partition wall could be open. I haven't gone up there and
What's a
poked.
partition wall?
In
Well, I know
between, interior wall.
Yeah, 'cause the knee wall.
Just separates that room from this wall.
Yeah, so we did this wall right here.
Yeah, that's a partition
Separating the
wall.
kitchen from the living room.
Oh, okay.
So those top, there might not be a top plate. It could just, those studs could go all the way to the top, to the floor.
There's no top plate.
Yeah, it could just be like a balloon frame and completely open.
Just all the
So
way.
that's kind of what they're talking about here, okay? So the partition wall are open to the attic, and in the attic there's a natural draft forced air furnace. Okay? Based on that information, what's the most appropriate recommendation?
So we're kind of like,
Seal openings and recalculate for the required mechanical ventilation. Yeah. Yeah, if there's an obvious air leak to the house, you're going to seal it up. The forced air furnace, natural draft furnace up there is irrelevant to that. Okay? Proceed with insulation measures. No, because it's going to have open bypasses. Install sealed combustion appliance. I mean, that's not solving that doesn't address the question. Recommended, sure, but it doesn't address the question. Determine how much of the leakage is coming from the ducts. Who cares? That's not what we're talking about. We have an open partition wall.
it's not fixing the problem.
Yeah, it's not even addressing the problem. So we're going to seal the opens, recalculate it. Because since we are lower than the ventilation requirements anyway, that means we're already adding ventilation. So what's a little bit more? Change the calculation, have the fan run a little bit longer. It's fine. But you don't overlook air sealing opportunities, especially if they're very low hanging fruit like that. How does an analyst determine the required mechanical ventilation rate? Well, you plug it into the standard calculator in your calculator. Okay, let's see if one of those
Standard.
is there. Measure with a blower door? No. No. If you know what your target is, but how'd you get your target? You did a calculation. Use a standard equation to calculate? Yeah. Use a standard equation for that area to calculate what it is. And it depends on where you are, what that calculation is. Reference weather history? Well, that comes into that standard calculation. Obtaining information from the manufacturer's data plate of what? Data plate of what?
The blower door.
There's a lot of data plates in play here.
Jesus.
Okay. All right. So we're going to use a standard equation to calculate it. Which standard? Depends on where you are. 12. What's the minimum net free area required for ventilation in a 30 by 40 attic that has a properly aligned thermal and pressure boundary, no vapor barrier, and no existing ventilation? Okay. So the key here is there's no vapor retarder. If there was a vapor retarder, the standard is
150.
1 to 300. Without a vapor retarder, it is 1 to 150. 1 net free foot for every 150 square feet of attic space. So 30 by 40 equals 1200. 1200 divided by 150 is what? 8. So your answer is 8 square feet. That's how many net free feet you need. Okay? 1 to 150. So you get the area divided by the standard, and that's the minimum standard. And there's lots of other things. Can you split it high and low? There's different things. But yeah.
So okay, you said so 150 NFA for no vapor recovery.
Yeah, if there's no vapor retarder.
VDR. And then
And if the thermal and pressure boundary are not aligned, then you don't the BPI standard is no ventilation at all until they are.
Just again, the equation would be 30 times 40 equals 1200 divided by 150.
Correct.
Okay.
Yes. You're going to get a 1 to 150
Did
ratio.
you say the other thing with the if it wasn't aligned with the thermal and
If the thermal and pressure boundary are misaligned, BPI standard is, you don't add any yet. It's not ready for attic ventilation.
right, because you have to seal it.
It's that.
Yeah, you have to do that first before you add any ventilation.
Isn't it? Yeah. Okay.
Address that first. Yeah. But once you have a pressure and thermal boundary, then you can add all the ventilation that you need. If you have air leaks in the house and you add attic ventilation, more path of least resistance is going to increase stack effect. And we want to stop stack effect. That's why. 22. What's an effective method to reduce indoor mold growth in a bathroom? Reduce water consumption, low flow. There's less water, no. Okay, that's, no.
Even that plays a role.
That's not going to
Pretty
reduce
small.
your mold growth. Steam is still going to be steam no matter how much water is, how many gallons per minute the shower is, okay? Adequate ventilation, exhaust ventilation. Yeah, install good ventilation. Okay, yeah, that'll do it. That'll remove that moisture at the source. Install an air filter with a high MERV rating. They'll pull all those mold spores out of it. No, that's not good. Apply enamel-based paint on surfaces prone to mold. That's not a bad idea, but that's not the control.
solving the problem.
That doesn't solve the problem. My house, when I just remodeled my bathroom, I was going to do that on at least the trim, but my wife's like, nope, I don't like glossy, shiny, I want eggshell. And so, I put a better fan in. The pressure pan inspection of a supply duct during a blower door test records a pressure differential of plus 10, plus minus doesn't matter, a differential of 10 with reference to the conditioned space. What's the condition of the supply duct inspected? So, it's a small leak. I wouldn't call 10 out of 50 a small leak, but we'll see if there's a better answer. It's a leak for sure. It's tightly sealed? Well, no, it's not tightly sealed. It's located in the conditioned space? That doesn't even make any sense. Ducts are conditioned space. It's mostly disconnected. No, mostly disconnected would be closer to 50. So 10 is not closer to 50. So of those answers, small leak. Which of the following is not a duct airflow testing protocol for a ducted distribution system? Let's see. Heat rise? No, heat rise is just the temperature difference. Static pressure drop? Yes. Pressure matching, like what we do with the better? Yeah. Dominant duct leakage? Yeah. Heat rise, that's just how much the airflow in versus the airflow out, how much is it conditioning? How much is it heating? What is most important for the design of a ducted distribution system? Using only one return per floor in the hall. Is that the most important thing? No. The return system depends on the house. Running the return ducts in or through the outside wall. Got to make sure you're punching them running them. No, that doesn't make any sense. No. Using a flex duct to supply air whenever possible. No, actually the opposite of that. You want to use flex as little as possible. It's way overused. And then balancing the supply and return airflow to each room. Oh, there you go. Yeah, that's pretty good. If we do a system balance, then it's going to work better, you're going to get comfort, and it's going to do what it's supposed to do. So of those choices, system balancing, yeah, that's the most important. What does the U factor rating on a National Fenestration Rating Council window label indicate? Does it indicate the entire assembly?
Yes.
Yes, to every part of it. Not just the center of the glass, not just the framing material, not the gas between the panes, it's every part of it. All done a weighted average. According to ASHRAE 62.2, what defines the pressure boundary of a home? The combination of sheathing and exterior finish materials like siding or whatever? No, that's not. No, I don't. We could look up ASHRAE 62.2. I'm not going to. The location of the insulation? Well, it's supposed to be. It's supposed to be, but that's not what defines it. The primary air enclosure separating indoor and outdoor air. Well, that literally sounds like the definition of the pressure boundary. Location of the vapor tight barrier. Sometimes. Number 28, which installation recommendation in the work scope will reduce indoor moisture related concerns? Bat insulation in an open floor separates the basement from the conditioned space. Little typo in there. No, the bat insulation is not there. Yeah, it might have a VDR on it, but it doesn't even say that. It says just the bat insulation. It's not specific enough. Additional bat insulation in an attic ceiling floor cavity. So in the not necessarily. Let's see if there's a better answer. Air sealing. Oh yeah, now we're into something. Air sealing of penetrations between a crawl space and a conditioned space. Yes.
Yeah.
Because you get that vapor in the crawl space. Air sealing of penetrations between a garage and a conditioned space. Of those, the C is the better one. What's the principal function of a vapor retarder? Is it to reduce moisture flow by capillary action? No. By gravity? That's like leaks? No. Reduce moisture flow by diffusion? Yes. And reducing moisture flow by air leakage? No. VDR is not an air barrier. So diffusion is a vapor diffusion retarder. Like the name. Number 30. When insulating two-story sidewalls, which platform framing detail is most often overlooked? So in a platform framing, you have your base, your floor. Here, we have a slab on grade. Okay, and then you set the walls on. Let's say there's another floor. You're going to roll out another floor, joists, and then set the wall on top of that. So it's going to have wall cavities until you get the floor, and then you're going to have rim joist, band joist. So what are they asking? Bridging? No. King studs? No. Band joist? Yeah. Collar tie? No.
I don't.
You know what?
Those answers. I mean,
you don't know what those things are?
well, I know what a rim joist is, but I didn't know a rim joist was a band joist. So I wouldn't know.
Rim joist and band joist is the same thing.
I didn't know. Yeah. But
So you have literally the rim where the joists are setting on, but then you have the long one where that rim doesn't have joists sitting on it because they run the length of it. Technically, that's the band joist. This is the rim joist, but it's the same thing.
I gotta look at all the names of all that stuff.
Yeah. 30. If an attic to be insulated contains a recessed light that's not rated for insulation contact, i.e. non-IC rated, and is not air sealed, what would the analyst recommend? Well, you're going to make sure that combustibles can't come in contact with it. There you go. Let's see which one is that. Seal the light fixture to the drywall with fire-rated caulking. Well, that doesn't make it non-IC rated. Encapsulate the fixture in two-part foam. Well, two-part foam is insulation, and it's non-insulation contact, so that's no. Install an airtight, fire-rated enclosure with 3 inches clearances on all sides. So you're extending the air barrier out to give it clearance from combustibles. That's okay, yeah. Add 12 inches or more of insulation and cover the fixture after air sealing.
Made worse.
Out of sight, out of mind. No. Airtight, fire-rated enclosure. Or, it's not listed here, retrofit it to an LED fixture. That's airtight LED fixture, and you're done. Okay. The scope of work calls for the installation of a 3-ton condenser. Which of the following is true about the equipment in this image? So here we have our data plate. Here we have a model number, and it conveniently has something highlighted for us. 36. So, what does that 36 mean?
3 ton.
3 ton. Why?
Each ton is 12,000.
Each ton of cooling is 12,000. Why? Why is 12,000 a ton of cooling?
12,000 BTUs to
Takes one
Remove.
BTU.
1 ton.
Ice block.
The ice.
The ice block? Is that what you're referring to? Is that ice block?
1 ton of
Yeah, it
ice
takes
block.
12,000
Yeah.
BTUs to
They were like, this isn't going to be on the test, but this is just kind of a fun fact.
Yeah.
And I'm just like,
Yes. So we're going to go one step more. It takes how many BTUs does it take to change the state from water to vapor? You're at 212 to go to 213 of steam. 970 BTUs to change it from 212 degree water to steam. That's a boatload of energy. That's a whole lot of energy because every degree before that took 1 BTU per pound. But that last pound to change state into a steam took 970. That's why our drip leg is so important. That it's not discharge tube is down and away from us so we can approach it because that steam is incredibly dangerous. Let's go to the other end and change state from ice to water. It takes 144 BTUs to change 1 pound of ice into 1 pound of water to change that state. And then that 1 pound of water at 32 degrees or 33 degrees to 34 takes 1 up till it's changes state again. So 144 BTUs per pound times 2,000 pounds a ton is 288,000 BTUs divided by 24 hours in a day, 12,000 BTUs per hour. Okay?
okay.
That's why. So that's why it's 12,000.
It won't be on the test.
That is going to
It's
be on
not
the
on
test,
the
so make sure you memorize that.
But now it's in your head.
6 million BTUs.
1
minus,
ton is 12,000 BTU. Can be on the
That's that is. Now keep in mind that when they're sizing them, it might not divide by 12.
Could be half.
Because the sizes go from generally on in residential they go from 1.5 to 5 ton on residential.
So the 1, 2, 3.
So this 36 would be
Could be
3 ton.
So 7th, is it always the 7th number equals the tonnage?
No, not always.
So it's going to be like
So how do I know?
24. It's going to be a 24, a 36, a 42, or
8 somewhere from 18 to 60.
it's going to be divisible by 12,000. 1 ton.
Well, not really, because if you have 42.
So that number's 36.
Oh, 36,000 tons?
Exactly.
A ton.
36,000
BTU.
Yeah, 36,000 BTUs. So if you see a 36, or so let's say you were to see a 24, you divide that by 12, and that'd be a 2-ton unit. See 36 divided by
So
12.
that's
is
talking
3
about
tons.
36,000 BTUs.
Yeah.
Divide that by 12 equals 3
Yeah.
tons.
Yeah.
So that's, so it's talking about BTUs then. It's not
Yeah.
talking about tons.
But what it's asking
Correct.
This
What
is
it's
asking
asking, like,
you,
what's
it's asking
true
for a
about-
3-ton condenser.
Yeah, if it's asking for a 3-ton condenser, after looking at that number right there, what's true about that number? Well, that means that it's
That's
sized
what it says.
correctly.
It's good.
Yeah.
Yes,
It's good.
it says 36,000 BTUs, which is a 3 ton.
Yes.
So it's sized correctly.
That's all I had.
So is it oversized?
36 tons.
Oh, no.
Is it oversized? Is it sized accurately? Does it match the evaporator? Well, where's the evaporator? I don't know. That's the one that like what? Undersized. No, it's sized accurately. Now, if it was calling for a 2.5 ton, it's oversized. A little bit.
Have you ever seen that on the test? Half ton?
Have
you ever seen half ton related on the test?
Mhm.
Or is it always you need 12,000?
There's half tons.
Okay. Just know that half ton will be how many BTUs have as well.
6.
So 3.5 it couldn't be 36.
42.
Yeah.
There's another one
So-
that it looks like it could be a 30,
But
but it's not.
302. 302. That's what that one.
Yeah, I'll show you later. What does the presence of soot accumulation on the burner access opening of a fuel-fired domestic water heater indicate?
Flame
That's soot. That's caused by the flame coming out. There's back pressure, the flame is coming out and it's not burning properly, it's leaving soot. And down there is where your unicorn will drop
It's not good.
if it burns it off. Because it comes out, that flame will just burst right out, and that means that it's been doing it for a long time. There's some consistent back pressure. That's backdrafting water heater.
So that doesn't have to do with the blower or leakage. That's from the gas. That's from the combustion.
That means there's not enough combustion air in that area. There's not enough combustion air, and it's not drafting out. It's got some sort of back pressure on it.
Yeah.
So if there's soot, that means there's flame rollout.
Watch your hair.
Which of the following methods does not help in reducing standby heat loss in domestic water heater? Will not help standby heat loss. Utilize a timer or an electric water heater on an electric water heater. Well, that'll help. Application of insulation on the water tank. That'll help. Use of a demand or instantaneous water heater. That could help. Installation of an expansion tank on the hot water piping. No. That'll stop water hammering, but it won't do anything about the heat loss. Which of the following can be categorized as a heating control that can be operated by the user? Low water cutoff, not accessible. Setback thermostat,
Yes.
programmable by the homeowner. Limit switch, no. Don't mess with those. Spill switch, no. The customer applied pressure override. Turn it off. Okay. What do the remaining amounts, 36, what do the remaining amounts represent when subtracting the annual base loads of electric and gas from the total annual electric and gas usage? So you have your kind of usage, and the electric will go like this. In the summertime, you use more electricity. In the if you have gas, it's going to be in the winter. You use more.
Seasonal. So you need energy use.
Potential for energy and cost savings. Actually, no. The base loads is where you get your most potential for energy savings. Energy is used to heat and cool the home. Ding, 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 ding. Total energy for 6 months? No, that's all of it. Energy is used to operate lights and appliances. No, because that's base load, and we've removed that. 37. If an analyst measures the flow rate of a lavatory faucet, bathroom faucet, at 16 ounces of water in 3 seconds, what's the calculated flow in gallons per minute? How many seconds? 3. How many ounces?
Per second. It'd be
16.
Oh, no. Don't do it for a second. How many seconds? 3. How many ounces? 16. So for each unit of 3 seconds, we're going to have 16 ounces. So how many units of 3 seconds are there in 60 seconds? 20. Okay? So 20 times are ounces. 16. Which is what? 20
320.
times 16 equals 320 divided by how many ounces in a gallon? 128. Bing, bing, bing. Alright? There you go. 2.5 ounces. 2.5 gallons per minute.
Divided by 1. No.
Whenever you said that here, I didn't really understand it, but I didn't really want to get too deep into it.
So when we did it here,
2.5.
we tested for 10 seconds, right? So what's and we got 47 ounces. So how many of those 10-second units are in 60 seconds? 6. So I'm going to go 6 times how many ounces?
47.
47 equals divided by 128, 2.2.
That was the one we did over there.
Yeah, that's the one that we did here.
Yeah.
We did in class. Okay, 28.
30.
Or 38, yeah. What can be determined using energy modeling software? Well, the output of an existing heating system. Well, I've looked at your heating system. It says it's an 80% efficient furnace. I put it through my software, and it's 80% because it asks me what it is. No, it's not going to tell you that. You put that information in. Okay.
Return on investment.
Return on investment? Yeah, it'll tell you that. Reduction in moisture load? No. Health and safety risks? Energy modeling does not address health and safety. It's not what it's for. An audit will, but an energy model will not. When energy consumption records are available, what's the minimum number of months of actual utility data needed to generate an accurate utility usage analysis?
Well,
1 year, 1 full year, all 4 seasons. Which of the following is most likely to be the cooling capacity in tons of a central air conditioning condensing unit with the model number CTF3611TI?
3 times.
It's the only one that divides by 12. Which data is not used in creating an energy model? Thermostat settings, humidity control settings, occupant schedules, local weather information. Humidity control?
No.
Right. What is needed to calibrate a building energy model? Energy usage history? Yeah, that's pretty old. Roof color? Oh. Type of heating fuel? That's irrelevant. Manufacturing date of the AC unit. Well, my house didn't have an AC unit until 6 years ago, so no. Energy usage, just so we know. 12 months, if possible. Okay, given the energy efficiency improvement measure of a material cost with a material cost of $100, labor cost of $400, and an annual cost savings of $25, how many years will it take for the measure to pay for itself? So that's payback. So the total cost divided by the savings. 500 divided by 25, 20 years.
It's gonna take some time to put that button good.
Yeah.
There you go.
Sure. We won't.
Which publication can be used to estimate both the material and installation costs of insulation measures? Residential Energy?
No.
No, that does not. It tells you lots of great information, but it does not estimate material and installation costs. RS means residential cost data.
Yes.
That's literally their job. Let's see if there's a better one. ANSI ACCA Standard 5? No, those are measures. ANSI BPI 1200? No. So I have the ANSI 1200 right here. Material cost. Oh, do. Okay. Nothing. Well, it's not that one. It's the RS means. 45. What can heating degree days be used to calculate? Building tightness limits?
No.
Internal heat gains?
No.
Maybe? No? Internal heat gains? No? No. Because it's external, right?
Those are cold.
Peak heating loads. Ooh, peak heating, no. Annual heating loads, yes. Annual heating loads. Annual heating loads. Because that's part of the equation. Because it depends on, you can build the same house in different parts of the country and it'll perform differently depending on the heating degree days. How are energy modeling results impacted by input errors related to the orientation of the building? baseload energy use. Ventilation requirements? Shouldn't. Domestic hot water needs? Shouldn't be affected by how the house is oriented. Return on investment? So it's return on investment or baseload energy use.
Base load because of the lighting loads. That's the only reason I remember I just did it last night.
Yeah.
Got that wrong.
Well,
Because whenever you change the orientation, it's related to
you change where the dominant heat is coming
Right.
from.
well, the lights. You get more light when it's oriented to east and west, so you don't need as much light bulbs.
Okay.
And
I mean,
the light bulbs is base load.
yeah. If the wall inputs, okay, 47. If the wall inputs of a building's energy oh, we just did that one.
Yeah.
48. When determining the overall heating and cooling loads for a project, which factors should the analyst consider in heat loss or heat gain calculations? Pool pump usage. Oh, that's a lot of energy for a pool pump. I mean, how much energy does your pool use? I mean, you get the bill, right?
I never looked at the bill, man.
Oh yeah. All right. Well, what about your pool?
Yes.
Yeah, big numbers on your pool. Your
I
pool?
don't have one, but I did.
I actually have.
Oh, you don't have a pool? Oh, I mean,
Expensive.
weird. What about your pool? You don't have a pool? What are the odds? 2 don't have pools out of 4? I mean, I don't have a pool, but I thought I was the weirdo.
Live no. Got
We
this
have
on.
pool,
I
man.
just said yes.
We just
Yes.
say we're good.
Hence, that's not the answer.
Okay, it's not the answer. Hence, that's not the answer.
Because not everyone has
It's
a
kind of like in
pool.
Right.
church, you say Jesus and all words. Like,
Most everyone has lighting. Let's see. Heating and cooling loads for a project. Exterior lighting loads? No. Hot water usage? Interior lighting loads. Oh, there you go. Heating and cooling, interior lighting loads.
Heat gain.
heat gain.
That's the key word.
How can spillage at the draft hood of a furnace be permanently resolved? The draft hood of a furnace. What kind of a furnace is it?
Natural draft.
Natural draft. So, by providing additional combustion air to the room, just adding more air, will that permanently resolve spillage?
No. Improving the pitch of the pool.
Improving the pitch of the flue pipe, will that permanently improve? Let's say we got this water heater and we just fixed the pitch. No. Installing a chimney liner, would that permanently resolve the spillage? Replace it with an existing furnace with a direct vent model. Yeah, that'll do it. All of those are parts of the equation. Parts of the equation. But what's the problem? Why is it spilling? We don't know. It didn't specify why it's spilling. So how do you permanently resolve it?
To definitely fix a direct vent.
Yeah. Replace it. It's no longer a natural draft. In buildings with attached garages, this is a repeat, which is the best way to enhance an occupant's health and safety? Eliminate pathways for pollutants into the living space. Yes. There you go. Maintain a positive pressure in the garage? No. Installing a vapor barrier? No. Providing properly sized gaseous carbon filter system? No. Why is the presence of pests living inside a residential home a health concern? Because they create allergens and can transmit diseases? I mean, yes.
It calls for curious.
They cause fear and discomfort.
Yeah, sounds good.
They are a nuisance and visually unappealing. They can physically damage the structure of the house. Well, it depends on the inside. Yes, A is true. A is true. They're all kind of true, but depends on how you look at it. So the one that's yes. What is the purpose of calculating the latent load of a building? Latent load, what's latent load? What is latent load referring to?
Moisture in the air.
Moisture. So what is the purpose of calculating the latent load of a building when determining the appropriate air conditioner capacity. Addressing pressure differentials? No. Overcoming heat gain from the appliance and lighting loads? No. We're looking at water. Removing moisture from the air? Bing, bing, bing. Compensating for system oversizing? No. Why should the analyst, 53, why should the analyst verify, what should the analyst verify before installing an air conditioning system as part of a replacement project? The proper amount of air conditioning refrigerant charge is based on the current system?
No.
No. Yeah, no. The amount of total distribution, leakage to the outside? We're replacing the system. The replacement air conditioner's capacity is based on the current system capacity? No. Replacement air conditioner capacity is based on the projected cooling load. Yes. There you go. What action, 54, what action is necessary if air sealing a house results in significantly tighter enclosure than the required whole building ventilation rate? So we've air sealed till we run out of the good stuff, and it was very tight. Do we install a carbon monoxide detector as part of the work scope? Not necessarily. Remove bypass seals? No, we're not going to undo our air sealing. Implement controlled mechanical ventilation in the home? There you go. No action necessary if there are no combustion appliances. And no one is living there. And no one is using oxygen. It's mechanical ventilation. Under which of the following circumstances should the analyst suggest relocating the thermal boundary of a home? So that means what? Like changing it from the ceiling to the roof deck, or from the floor to the sidewalls, or something like that. We're moving the thermal boundary. So there needs to be a pretty good reason why. So when insulation is misaligned with the pressure plane, yeah. We got a pressure plane, make sure if it's over here, the insulation is here and the pressure plane is here, yes, move it, align them. So you don't have a bypass. When new windows are installed, no. Basement is unconditioned, no. When the measurement of CFM50 exceeds the required ventilation rate, no. What can infrared thermography help identify? Level and performance of insulation? Yeah. Especially like fiberglass in walls. Air leaks? Yeah, with the blower door and a temperature differential. Temperature? Temperature and moisture interaction. Temperature and moisture, yes. All of the above, yeah. I don't remember ever seeing an all of the above question on the exam though. So make sure you're reading them and knowing what they're asking. Because this is just covering topics. Just keep that in mind.
Oh, this one got me.
Which?
This one got me good.
Okay. Which of the following improvement recommendations has an incorrectly listed savings to investment ratio? Well, let's calculate and find out. Number 1. How do we do an SIR? Savings times life divided by cost. Savings to investment ratio. That's literally savings over investment. That's the equation. So the furnace is 600.
6,000.
Annual savings.
Oh.
600 times years. 25-year furnace. That's a good furnace. Equals 15,000 divided by the cost, 6,000. 2.5. No, it says 2.5.
Or
SIR is correct. Okay. Let's look at the attic insulation. It's going to save me $325 and it's going to last me times 20 years, and it's going to cost me, divided by my cost of $1,500, gives me an SIR of 4.33. This says 3.33. That's incorrect. Window upgrades. I'm going to just check it out. Why not? So my annual savings are $200. Wow, those are some good windows. Times, so they're not that great. They only last 10 years. Equals $2,000 in savings, and they cost me $1,200. Those are some magic windows right there. Oh, shoosh. I did my equation wrong. 200 times 10 divided by 1,200 equals 1.6. What's that? 1.7. Yeah.
Round up.
Yes. So those magic windows pay for themselves. So the one that's wrong is the attic insulation. Here's another magic window. A replacement window costs $200. And to install, total, install and window, $200. That's a bargain window. And saves you $20 every year in electricity cost. The window has a useful lifetime of 25 years. What's the savings to investment ratio for that window? Well, it costs me, saving me $20 a year, and it'll do it for 25 years, divided by the cost of $200. Gives me a magic window of 2.5.
A unicorn window.
Yeah, seriously, buy them all. Buy all those windows. Because that one lasts 25 years. That other one, they were only 10-year windows.
I have a 100-year window.
They're expensive too.
Attic insulation retrofits will cost the customer $3,000 and last 10 years. The annual savings are estimated at $40 a year. What's the simple ROI for these? Let's see. See if I can do this equation right the first time. Yep, there you go. So I got
10
my
years times.
savings times my years divided by my cost. 0.15, which like U value is a percent. 1 would be 100. Anything below that is a percentage. So 15%. So I have a 15% annual return. Huh?
Yeah.
You did 450 divided by 3,000.
45. Yeah, 450 divided by 3,000. 15% return on my investment annually.
So it's savings.
Savings to investment ratio is a little bit different. Yeah, they're kind of same thing.
So ROI and SIR are the same thing.
No,
Or you use the same? You did the same.
it's a similar calculation.
Yeah, you divide the little number by the big number to this percentage. The other one you divide the big number by 1.
Yeah. What 60? What is not a way to reduce lighting load in a home? Install motion sensors. That'll reduce it. Orient a new home to have more windows facing east and west. So pick up the house and move it. Okay. Install skylights in existing homes. Installing timers. Ooh. Well, it's kind of expensive. Yeah, we're not going to reorient the home. Okay, that's silly. That's just silly. Okay, clear my choice. I'll show you the map. A lot of people getting this wrong. During the initial audit, the infiltration rate for an existing home is 3,500 CFM 50. The work scope calls for a 35% reduction in air leakage. What is the target infiltration rate for test out after the air sealing is done? What do we want?
We want the walls of your fence times 35%. Take that number and then subtract it from 3,500.
3,500.
Okay, you can do that. A simpler way, I have lazy math brain, so I like to do it a different way. What's left How much are we taking away? 35?
Oh, so
What's left?
you're doing 50,
65.
yes.
So I'm going to take my 3,500 and times it by my percentage, 0.65.
We did 2 math problems, you just did 1.
Yeah.
But it still works.
Yeah, it
That's
works.
the one you remember, then you can do that one.
Yeah.
Alright.
What's cool about math is there's a couple ways you can attack it usually. Okay? So,
That's the same way I did.
yeah. There's people with math brain,
It made more sense to me to do it that way.
people with like analytical math brain, not me, will be like, this was bing. I mean, like, this. How's that?
Jason, teachers, that makes sense.
Yeah, show me all your
To show me your work. Okay, so
Wait, we do that? I know we didn't, sorry.
62. Here's a good one that you'll get to. We've talked about it. According to national and international fuel gas codes, using the standard method for determining the adequacy of a space to provide combustion and ventilation air, which one of the following is the volume required for a 100,000 BTU gas heating appliance? Don't you love how they word these? Like, if you have 100,000 BTUs, what do all the standards say that you need for volume?
50 per
50 per
1,000.
Right. How many units of 1,000? We have 100. 50 times 100 equals? Bingo. Is this picture familiar?
One of my
You've
favorites.
seen that before. Based on the manufacturer's tag, how many tons of cooling does this AC unit provide? Well, in the model number, it's going to have some stuff. It says VSX 13024. Okay, is it the 13?
No.
No. Is it the 30? Yeah, it divides. It divides. That would be 2.5 tons. Do we have that answer down here? No, we don't actually. So on the test, I think you do have that possibility because it gives you bad math answers. So if you do bad math, there'll be an answer for it. If you divide by 12 instead of 144, there's an answer for that. So if you do bad math, like in other equations, they're notorious for that. Anyway, so 30 does calculate right, but that's not. 2402, no. 24, well, that divides by 12. That's a 2 ton. 41, that does not divide. So it's either a 2.5 or a 2 ton. Well, if you know that the 13 is the SEER, so it's a 13 SEER, then, and usually, or very often in the model number, the tonnage will be preceded by a 0. So that says 24.
Okay, so tonnage preceded by a 0.
Often.
And then the first 2 numbers are the SEER?
On this one, not all the time. Unfortunately, there
There are
are
questions
not,
on this, and it's like it's all
unfortunately, there are
Depends
not,
on the manufacturer.
yeah, it depends on the
Some
manufacturer.
Give you the series before they give you the tonnage. Just look at the key valve and determine that's a 3/4.
So you're saying it's because the 0 is before the 2.
Well,
That's
the
what
easiest
she-
thing is to check the access label on the Marciano pump, and it'll always just say in plain English, but there's no such thing as any of that. I just made all that up.
First 2 numbers are typically 0.
I don't know, but it seems like once you already are used to seeing
So I
model
like it.
numbers, it just gives it out to you.
And then at 0, a lot of times, but there's going to be before the tonnage.
Yes.
So that 0 is there because of that, not too many.
I'm sorry. Okay. I just don't want to get on higher.
So we're on 64.
We are.
See if I can get a better picture of this one, of this picture. It says, which recommended improvement will not pay for itself over the lifetime of the
Windows.
improvement? Let's find a better one.
I did the same thing that I got it wrong.
Really?
Yeah, they're all the above.
Right?
Like, they're all under 1%.
Anything with a savings to investment ratio under 1.
Oh, under one, right?
Anything under 1. So let's see if we can.
Yes, I don't know what.
Okay. Here's the SIRs.
Oh, nice.
Here's the improvement. Here's the line number. Labor material total. Okay.
So,
Now I believe on the exam it asks you something about what's true about line 16. Which guess what? That means you can ignore everything except line 16. What's true about it? Well, what do I know about it? Well, it won't ever pay for itself, not even a third.
even if anything under 1 won't pay for itself.
Yeah, it's 0.3. That'll recoup 30% of its cost over its lifetime. The labor is $600. Material is $1,600. The total is $2,100. It doesn't give me years, so I can't calculate if that SIR is correct. But based on that line, what do I know about it?
It's not gonna pay for itself.
It's expensive and it won't pay for itself. That's what I know. So let's see if there's an answer. What the answer is. Will that... So of this, the water heater has an SIR of 0.67. The central AC has a 0.3 and the refrigerator has a 0.28. All of them have it under 1.
So what's the question though? Because it says what's true about
This one, no.
He's saying the one on the
On
final
the-
test is going to say, what's true about line 16? So
Uh,
this one is saying,
This one says which one will not pay for itself. Those 3 won't pay for themselves.
okay.
So of the answers, all 3 of those are listed, but it does have none. All of them have. All of those 3.
to report back to the PDFs on this. Because they'll probably,
It'll have a picture that comes up. So, which of the following ACCA manuals is referenced for duct design? Manual D
For that part.
for ducts. I think that's the only one that works like that though. Manual J for sizing.
it's not like wondering on the final, are they going to ask like, which one of the following ACA manuals refers to, and then a different one, since the duct one was in the practice questions.
Well, the only 2, I don't know. The only 2 that I know for sure are Manual D is for equipment sizing, and Manual J for equipment sizing, Manual D for duct sizing. And I think one of those is made up. I'm not sure.
That's the only 2 that I
That's
got.
equipment. J is your loads, all of your
Yeah,
loads.
your heat load
D
calculation.
is duct design.
Is what?
Duct design is
Yeah.
D.
And P, is that even
Never
a
heard
thing?
of it.
Yeah, I don't think that exists. I think that's real.
S is
Ma-
equipment selection.
Equipment selection, yeah. So this is for sizing your equipment.
Yeah.
Manual J is your heat loss calculation to size your equipment. Manual D is for duct sizing based on the equipment, and this is for literal. The S is for specific
Equipment selection.
equipment selection.
And what is it asking for? Duct design.
J is
Yeah.
loads.
A is duct design. J is your loads.